This is Algebra 1, Term 2, Lesson 14. This is the last lesson in Term 2, and we have 3 parts with a little mixed in practice for different concepts to get ready for our term exam. So let's start with the Desmos activity. This activity is going to be about a race between 2 individuals, and so in this race they're going to watch a video. So as you see, there's 2 men in the race, and the goal is to predict where the man in the suit will catch the man that's not in the suit, and that's kind of the whole task. So they will be writing systems or a system of linear equations to help with that task. They will also be looking at multiple representations, so not just a graph, but also a table, and then they're going to basically refine their prediction based on their graph and their table. They do give them an equation as well, so that will be their third representation, and then they will make their final prediction. On this screen, when they play the video, it will create the graph to match the video, so they'll be able to see if their predictions are correct. Now, at this point, you'll want to make sure you have paced your kids, because once they get past slide 9, this graph that's going to show here will be displayed on the remainder of the graphs. So you don't want them seeing slide 10 or later while they're working through. So be sure that you pace your kids to not advance past slide 9, or actually past slide 8, because they could play this video and see this graph before they get here. So once the class has kind of wrapped up their work, they'll be here. Now, I'm assuming at this point the kids have gone fairly quickly through this task. I have scheduled this lesson for 1 to 2 days. So this first part up through slide 9 should go fairly quickly, because it's pretty simple. And again, we're just making predictions here. But once they get past slide 9, they may need to slow down a bit, because I have added in quite a few concepts. I will be blurring the graph on the next few screens, so not to ruin this activity for you and your students. All right, so here we are on the next screen. The graph is displayed. They will see that. It also gives the time. Well, I'm not going to tell you what's in the graph, but I'm going to have them answer a question about the time, and then they'll explain how they figured that out using either tables, graphs, or equations. And then they're going to write piecewise functions for Rich and Julio. If you remember, one of the guys stood back and waited, so he's going to have basically a piecewise graph, and so they'll write equations for those 2 pieces and then one for the others, and they will restrict their domains. Now, I did give them a graphing calculator. It will not graph over the graph that's here, but they are able to check their answers if they want to recreate it in Desmos. Please read the teacher moves and sample responses if you're unsure about how to write these. Any equation that is equivalent should be accepted at this point. The statements that apply to this in context, so they're going to talk about the domains, whether this should be continuous or discrete, and what the rate the units are for rate of change. And then the next one, they're going to evaluate and interpret the function at 2. So what are these values and what do they represent? Now, they will use their functions that are on screen 7. That was given, by the way, and 11, that's the one they wrote. So, and by the way, they won't have to create these equations completely from scratch, because they were given equations in the task. They're just kind of modifying them a little bit to restrict domains and to use the function notation. So hopefully that's not going to take them too long to get through that piece. But this is where it could take some time. The very last slide is here for them to create a function to represent their distance from the starting line. So they're going to add themselves to this race. And so they can make a decision as to, I want to win this race, or maybe they don't care if they win this race. Maybe they're going to run a lot slower. And so they can add a line or a piecewise function to this graph to describe their race. And then they will describe it in words, what happened. So there are sketching tools here. Be sure to let them know they do have a line tool. They might want to try that instead of freehanding with a pencil. create an equation. So when they type the equation in this box, they will use the math tool. And of course, they can upload a picture if they want to write on a whiteboard. Some kids prefer that to typing, so that's fine. But this would make an excellent portfolio artifact. So I encourage you to encourage them to do their very best work here so that they can showcase what they have learned about functions, piecewise equations. I mean, there's so much in here they could showcase in their portfolio artifact. So this activity, I'm guessing, will take the bulk of your time in this lesson. And then we have a few more things to do. So let's look at the next activity. So the next activity is Pixel Pattern by Dan Meyer. You may have seen it before. You will play a video for your class. Now, unfortunately, this is not a video. You will have to download the video to show it. He does not post his videos online where you can play them, so you will need to download and play. And then once you've done that, you can start asking some questions. When will your pattern break the box, and after how many seconds? Write down a guess. Let me show you some information that you will want to provide for your kids, and this will be in Act 2. So this is your Act 2. You're given the dimensions of the box that's in play here. And then you're given the dimensions of each little piece, and you're given the time stamp here. And then the next one is a PDF. Now this is one that you would basically print off. If you have your kids in an LMS, I encourage you to give them a copy of this actual document because it does have the color in it. Now, your kids that are not able to see the color, they can see the letters associated with the colors so that they're able to make sense of what's happening here. But here's the timestamp, and this is showing you how many blues, how many reds, how many greens, and then they can kind of follow the pattern here. Each kid, or at least each team or pair, however you want to do it, need a copy of this particular piece of paper to make sense of what's happening. And then the last thing you'll do is do the Act 3, which will give them way more detail. It gives them the full video, and then you can see if they've gotten a correct equation to represent their pattern. I have given you some slides to put this on, and I will show you those next. So as you can see, the slide has very little on it. I've just given you Act 1 pixel pattern, and you will show the video in front of the class. Like I said, we don't have a link to like YouTube for this, so you will need to show it to the class and ask them what is happening, and they can just type some thoughts here. You can direct them if you want something specific on Act 1. And then on Act 2, they're going to use the handout that I just showed you to generalize this pattern and answer some questions. So you will provide the questions that you want them to answer. There are 2 suggested questions on the site, but you may decide to add to that or do it, take it a different direction. Ask them to include a copy of their work on this slide so they could write on a whiteboard, they could write on paper, however they choose to do it. They could even write on that handout that you've given them and put that here on this slide. They may also decide to go to Desmos and create the equation of their function and, use that. Make a table of values, and there's lots of possibilities here. Now, I have included some slides about sequences as a refresher because the exam will be happening next time. So here's the sequence. I'm asking them to write an equation and graph the sequence and insert on the slide. Now it's important for them to remember this should be a discrete graph, not a function, not a continuous function. So be sure that they know that. If they don't, you may want to have that discussion if you're seeing kids just graphing lines for this slide. And then this sequence, we barely talked about this since the beginning of this term, and this was your Fibonacci sequence. So again, refresh their memory. Well, how did Fibonacci do his sequence? And just to remember the name, because this may pop up on the term exam, and we don't want to trick them or trip them up because it's not something they've seen in a while. And then here's another sequence with a visual pattern. What is the 5th term of this sequence? And then fifth term being the number of blocks in the pattern, if they're wondering, and then create an equation and a graph for the sequence and insert on this slide. Now they could actually draw in, if they want to use the drawing tool, they could actually draw in another one if they want to, but that's totally optional. So on the last slide, students will create a regression equation, a correlation coefficient, and a residual plot. The data will be given to them already in Desmos, and they will create a graph, an equation, correlation coefficient, and plot residuals, and insert a copy of the graph along with their data on this slide. There is no context given, so kids can maybe create a context, but if you don't have time to do that, then you can just skip that part or skip that question and delete it from your student show notes. Let's go ahead and look at the data that they'll be graphing. This is the Desmos calculator. As you see, the data is already graphed for them. So all they're going to do is go down to the bottom here and type y1 tilde mx1 plus b. It will create their regression equation. It will show the correlation coefficient, and then they'll click the button that says plot residuals, and it will add those to this graph. And then they will take all of that and put that onto their slides. And that's it for the slides. Our last activity will be a graspable math activity. So this is what it looks like. It's very short and it is super simple, I hope. At least it was intended to be. So let's take a look at what this might look like. On this activity, they will be graphing a line. So over here, if you'll click on play, you can watch the video and it shows them exactly how to do it. Now first you create the line by just clicking on the canvas anywhere and it'll pop this up. You type that equation in and then you drag the gray dot over. Now I've already done this in the video, so I'll show you that now. So you click on the canvas, you type in the equation of the line, click the check mark, click on the little button to the right and drag it over to the graph and release. Okay, the next slide we're going to write and graph a line. So first you click on the canvas, you create the equation, you drag it over to this graph. This function is named F. It'll turn into a G if they've graphed it correctly. We also have some multiple choice questions. Here we have another one, graph a line. See if you can match this one. So create an equation and graph it. This one is line it up. So when they click here, they're going to move these values up and down in order to get this line to match that line. So I'm not going to do it for you, but once it is correct, this will turn green and they'll be able to go to the next slide. This is a multiple choice test. If it's correct, this will pop up green with a check mark. Now they're creating an equation for the sequence and it will connect the dots, but we know the graph of a sequence doesn't really connect the dots, so this is just a means of checking their equation. Is this an arithmetic sequence? And then they need to type that down here, why or why not. Here again they're graphing, so they'll click this and then they will graph the line. So when they click here, it creates another line. They will move these up and down, or they can click and type in the value for the slope and the y-intercept. Multiple choice. So as you see, it's just a real variety of things for them to do. Quick practice of some basic things just to make sure they're not struggling on some of the basics. So this concludes Term 1 lessons. We will have our term exam next time. The guide, the course guide, will be available, posted at technomath.com. And the paid version will be in the store. The free version will not have the answer keys. It will not have the tests, but it will have all these activities. So if you're wanting to, like a Desmos activity, graspable math activity, whatever's out there that I've either created or curated, you will have a link to that in the free version. If y'all have any questions, or if you need some help teaching a certain concept and you're just not getting what you need, let me know. I will be sure to help you out with that. Y'all have a great day.